Hey there, algebra pre-calculus. Today we're going to do 4.9, solving polynomial inequalities. Now I did some work here I'm going to explain what it is, and then I'm going to do a problem where I do the work all the way through, and then I'll do a problem that has like a different scenario that occurs. But I do want to mention about the tests. The tests are graded. You should got your grade back through Google Classroom. If you have any questions, I'm not in the school right now. I'll hopefully be in by lunch. If I am in by lunch, then if you find me or you want to text me where I am, I'm happy to help you out. All right? Otherwise, let's just go through today's lesson. Let's do it as fast as possible. Okay, so this is a worked out example. So what today we're doing is inequalities. Remember, inequalities are that greater than or less than sign. So what we're going to do first, don't look at this side over here, but what we're going to do first is just solve it as if it was equal sign. So solve it as if it was equal sign. So I would factor out a y here, and then here and here, I would just make this 0 and 3. So that's pretty easy. This is a simple question. But when you have an inequality, you have to take an extra step. And we're going to go to this number line. So let me talk about what's happening in this number line. From here, we have 0 and 3 being our root points, okay? So 0 and 3 are our roots here. And what we're going to do is test each section of the number line. So in this case, it would be less than 0 over here. It'll be between 0 and 3 over here. And it'll be 3 and greater over here. So I'm testing all that. How do I test each section? Well, I just take a number to represent this section. So anything less than 0 will work in this section. So -1 works. So I took a -1 and plugged it into the original. You could technically also plug it into the factored form. -1 squared is a +1. And then -3 times -1 is +3. So that ends up being 4. The key thing is I don't really care about the number I get. What I really, really do care about is the sign. So the thing was +4. So that's a positive number. Let's go to our next section, B. Next section B, we just have +1. Or it's between 0 and 3. So I have to pick a representative. I pick 1. You could pick 2. You could pick 1.5. You could put 2.99999. It doesn't matter. It has to be one number here. I suggest picking the easiest number of the group. And I think 1 is easier. So I'm going to take 1 and plug it into here. 1 squared is 1. -3 times 1 is a -3. That ends up being -2. As I said, I don't really care right here. I don't really care about the number. I just care if it's negative or positive. This one is -2, so this is negative. So I'll put a little negative sign on top of this section. Last section, we're going to plug in 4 into the original equation. This one, I'll plug it into this one. I feel like it's easier just to plug it in here. So I'll have 4 times 4 minus 3. 4 minus 3 is 1. 4 times 1 is 4. Here, again, a positive number in particular. So I'm going to put plus sign here. Now we filled out this number line. How do we choose how to color it in like I did? Well, in the original equation, it is greater than or equal to 0. So it's greater than or equal to 0. So I want to see which parts give me positive numbers. I want to see what parts give me positive numbers. And the parts that give me positive numbers is here when 0 and to negative infinity, and here where 3 is to positive infinity. So if I were to write the domain here, the numbers I could plug in that causes this situation, it's going to be a soft bracket, negative infinity, because I'm coming from negative infinity, running all the way to 0. So this one will be a hard bracket, and the reason it's a hard bracket because it's greater than or equal to. So because it could be equal to, I use a solid dot here, and I use a hard bracket here. Union, again, not necessarily that bad, but hard bracket 3, comma, to infinity. Again, hard bracket on 3 because it's greater than or equal to. So that's our answer for our first example. I'm going to do about 2 or 3 more. All right, we're on our next example. Y cubed minus 8y is less than or equal to 0. Okay? So y cubed minus 8y equals less than or equal to 0. So I'll go through all the steps. First thing, we want to factor it as if it was equal sign. Seems like they both have y, so y squared, y minus 8 since now everything here is being multiplied, oh, I'm sorry, I said y squared here. It's y over here, while it's y squared in here. It's less than or equal to 0. So if I were to solve this part right here, plus 8 on both sides, 8, and then square root both sides, so that's y equals plus or minus 8. Don't forget that, plus or minus 8. And this one is y equals 0. So your root points are here, 0, and both negative and positive 8. So you're doing the roots of 0, negative, and positive 8. So when I do my number line, I'm going to have 3 root points. Negative 8 over here, 0 over here, and 8. Again, the number line is what's unique in the inequality. Here, you'll be done if it was just an equal sign. So, what we're going to do is test each section. I'll just call it A, B, C, D. You don't need to label it A, B, C, D when you do it yourself. It's just for me to explain what section I'm at. So section A, I need a representative for section A over here. So A has to represent something smaller than negative 8. I'm going to plug in negative 9. Okay? If I plug in negative 9, what I'm going to get is I'm going to use the factored form because I think it'll be easier in this situation. But the factored form is negative 9 times, this is going to be 81 minus 8. This right here, even if I don't do the math, I know it's going to be positive. But like, I'm just going to tell you how you can do it quicker. Here, you know this number is going to be positive on the right. Here, you know this number is going to be negative. A negative times a positive will give you a negative number. Remember, we don't actually care about the numbers we get. We care about the sign they are. We don't care about the numbers that result in our tests here of this section. We care about the sign of it. Let's go to the next one. B, over here, from negative 8 to 0. So negative 8 to 0 in section B. We're going to plug in something, probably negative 1. I think that would be easier. Negative 1 is so easy, I'll just plug it in at the top. Negative 1 cubed is still negative 1. Negative 8 times 1, negative 1, will be a positive 8. So negative 1 plus 8 will give me a positive number. So this right here is a positive number. Okay, so from here, section B is a positive number. Section C, you got to plug in a number that fits. 1 is in between 0 and 8. Plug in 1, you'll get 1 minus 8, that's a negative. And over here, I'm going to plug in a 9. So 9, I'll plug it into the factor form. It seems a little bit easier. Again, it's up to you to choose, but I'm calling it that's going to be easier. So 9 over here is positive, and then when I plug in 9 over here, it'll be 81 minus 8. That's also positive, so this will be a positive number. Because positive times positive will give me a positive number. So I'm looking for things that are less than or equal to 0. So that's going to be, and it's equal to, so a solid circle over here, all the way down to negative infinity. And then between 0 and 8, we have a space right here. So our domain for this one is going to be from soft bracket, negative infinity. Sorry for the crooked. All the way to negative 8. Since I'm including negative 8, it's a hard bracket. Union. Hard bracket 0 to 8. Hard bracket. In that case, we're done. 9 does not make it less than 0. Something between negative 8 and 0 doesn't make it less than 0. So because of that, it's only this set right here. So your domain should be in that set. Okay? Well, a couple more examples. So here's the next one. It's a bit tricky. Notice how it doesn't equal 0 right away. So we're going to have to do something about that. But first, I see this and this. I'm going to subtract this part right here to make it equal 0. So I got y plus 1. Y minus 1, and I'm sorry if I speak fast, but I figure since you could pause the video, you can just stop at any moment. So I'm just going through it quickly. Minus y plus 1 is greater or less than 0. I subtracted y plus 1 on both sides. Okay, so before I can interact with this, I have to FOIL this out. So I'm going to FOIL this out. Y squared, this is plus or minus 1, so that's negative 1. Minus y plus 1, something that I saw in the test a lot. When you subtract, you have to make sure this also gets a negative. You can think of it as distributed. So y squared minus y, this is just a normal y, so they can't interact. And negative 1 minus 1 is negative 2. is less than or equal to 0. From here, we want to factor that out. So things that multiply to negative 2, that add to negative 1, that's y minus 2 and y minus 1, or plus 1, I'm sorry, plus 1. So less than 0. So we want to find our roots. In here, it's going to be positive 2 and negative 1. We just found our root points. We're going to use this on our number line to test the inequalities. So the inequalities here are from negative 1 and 2. So section A, B, and C. Again, you don't need to letter them. That's just for me to describe it a little better, especially here versus in class. So we need something in section A, negative 1 or less. So I'll just put negative 2. So for negative 2, let's see. It'd probably be easier to plug it into this original form. Why? Because what I do here is I say, if I plug it in negative 2 here, I'm going to get a negative. If I plug it in negative 2 here, I'm going to get a negative. Oh no, I wanted it to equal 0, I'm sorry. So let me put it in this second line. If I plug it in negative here, I'm going to get negative. If I plug it in negative 2 here, I'm going to get a negative. And if I plug it in negative 2 here, I'm going to get a negative. So negative times negative, which is positive, minus a negative, which will be positive. So positive plus positive has to be positive. So sometimes you don't actually need a number. As I said, you just need the sign. Let's look at the next one. From negative 1 to 0, 2, so 0 is a really easy number to plug in. If I plug in 0, I get a positive 1. Here I get a negative 1. Minus, if I plug in a 0 here, I get a minus 1. If I plug in 0 here, it would be minus 1. So 1 times negative 1 is negative 1, minus negative, oh no, this is minus 1. I should say this is a positive 1, so minus 1. So let me reset. 1 times negative 1 is negative 1, minus 1, that'd be negative 2. This would be a negative number. And then we will plug this up in here. Let's plug in 3. If I plug in 3 here, this is going to be 3 plus 1, which is 4. Again, sometimes I show you with the signs, but you could just use the numbers anyway. 3 minus 1 is 2, so positive times a positive, minus 3 times plus 1 is just 4. So 8 minus 4 is a positive number, so positive here. Okay? Now you might notice, usually it's a pattern of plus minus plus minus. That is usually true. It's going to be a pattern of plus minus, unless you have a double root, and I'll make an example of that for our last one. So over here, test it out. Things that are less than 0. So less than 0, that's negative numbers. We're going to use an open circle because it's less than and not less than or equal to. So we just scribble this here. So our domain, soft bracket, negative 1, 2, 2. Soft bracket again. That's it. We don't go to negative infinity. We don't go to positive infinity. We just have between negative 1 and 2, not including negative 1 and 2. Now you notice the pattern as I said. We'll do one more where that pattern doesn't hold. All right, our last one. X squared times x minus 2 is less than or equal to 0. All right, it's less than or equal to 0. Okay, so this one we're solving for this. If x squared, it's already factored because I'm trusting that you guys know how to factor your things out. If not, you're going to get a lot of practice during the homework anyway. But x squared is going to equal 0. And over here, x minus 2 equals 0. So you got a positive 2, and you have square root both sides 0. All right? So what is going to happen here? Well, let's plug in. We have our root numbers, 0 and 2. Let's make our number line. 0, 2. We have section A, B, C. We already have our root numbers. So A, B, and C. So let's plug in A. So something for negative 1. Negative 1 here would be a positive 1. 1 minus 2 is a negative 3. 1 times negative 3 is a negative number. Let's go to the next one. Between 0 and 1, 2. So we'll do 1. Plug in a 1. It's 1. Plug in 1 here. It's 1 minus 2, which is negative 1. Multiply, it's also negative. So you're like, wait a second, usually the pattern is negative, positive, negative. Because at this point, it's technically a double root here at 0. It's technically a double root, so x squared equals 0. Because it's a double root, what happens is this root point is called something else called a inflection point, which means it doesn't change when you cross over it. When it's a single root, like here, and I'll just plug it in to prove it, so this is 3. So 3 would be 9 over here. and then 3 would be a positive 1. 9 times 1 is positive. When you have a single root, it'll flip over. But when you have a double root, it doesn't flip over. Now, I do suggest always plugging it in the number line. If I was doing this as a student, I would plug it in the number line. But knowing that pattern will help you check your work a little bit better. And if you see something doesn't match your pattern, then you say, I might have made a mistake, or am I reading it wrong, okay? So I'm telling you that pattern to help you guys understand it a little bit more and deeper. So because we have that, we need sections that are less than or equal to -1, so negative numbers. So we could put a solid circle here and scribble. And then we could have put a solid circle here and scribble. Now notice, the line in the middle right here is also solid. So it includes everything less than 0, exactly 0, and more than 0. So because this point is solid and overwhelmed by both sides, you could just run right through it and go negative infinity to positive 2. There's no need, hard bracket positive 2, I apologize. There's no need to do it like this. 0. And then 0, 2. There's no need to do it like that, because since you're including 0, because 0 is included, you didn't really describe anything in between that's not included, right? If it was soft brackets, then you say, oh, 0 is not included. But here, since 0 is included, every number is smooth. So this would be your final and correct answer. That would be slightly incorrect. I would probably, if it was a 3-point question, take half a point off for that, or maybe a point off, I'm not sure. So here, negative infinity to 2. All right, your homework is going to be posted on Google Classroom, and your homework is going to be doubled in terms of value. So instead of 2 points is 4 points, and the reason it's being doubled is because it's going to be your classwork and your homework grade, okay? If you have any questions, you can email me or text me. My number's on the syllabus if you still have it. If not, it's like the first post in Google Classroom. Otherwise, have a wonderful day.